My name is Niels-Erik Clausn, and I will talk about the need for wind energy. After this lecture, you will be able to explain the global need for wind energy and to mention the most important issues when you're planning a land-based wind farm or when you're planning an offshore wind farm. First, we will look at the global challenges of climate change. On the left-hand side, you can see the global monthly mean of CO2, carbon dioxide, in the atmosphere of the Earth. And you can see that it's increasing gradually from 390 to 400 parts per million. What you can also see is the red curve, which shows that the CO2 content of the atmosphere is increasing in the winter time and decreasing in the summertime when we have the photosynthesis active. On the right-hand side, you can see the increase of global temperature from all the meteorological stations in the world. And this is from 1880 to 2015. And you can see that the global mean temperature is increasing all along those 135 years by 1.4 degrees Celsius. The need for wind energy in the energy system is to replace fossil fuel-based electricity generation, as we have seen, to combat climate change on a global scale, but also to mitigate environmental concerns, which is more on a regional or a local scale, which is associated with fossil fuel-fired power plants' emission of particles, nitrogen oxides or sulfur oxides. Wind energy is also increasing the security of energy supply of our energy system because it is a domestic fuel that we don't need to import from politically unstable regions of the globe. It is cost competitive with traditional power generation, and it provides local employment and regional economic development. It can be installed very fast compared to conventional power plants. What we see here is the very fast increasing rate in which we have been installing wind energy. On the right-hand side of the graph, the green numbers and the green graph is showing how much is installed in megawatts every year. And the blue curve is showing the accumulated installed capacity of wind energy up to 400 gigawatts of wind energy. So we have now more than 30 years of experience in more than 50 countries, and the offshore part of the market is about 2%. In 2014, wind energy generated 3.4% of the world electricity demand. In Denmark, we started quite early by installing wind energy on land already in the late 1970s. And as you can see now, we have wind turbines pretty much all over the country, with a higher concentration in the western part of the country where the wind resource is the best. Totally, we have 3.6 gigawatt installed land-based, and we have more than 5,000 turbines installed on land. In 1991, we also started installing wind turbines offshore in Vindeby here, and today we have now offshore turbines in more than 13 locations, totally 1.3 gigawatts. The wind turbines generate approximately 13.5 terawatt-hour last year, which corresponds to 40% of our electricity consumption. So we have transformed our energy system from a centralized power system to a decentralized power system. In the 1980s, we have 15 centralized power plants spread over the country. That's the red dots. And today we have also 15 power plants. They have now been converted to combined heat and power plants, so they are both producing electricity and heat. On top of that, we have installed 415 decentralized combined heat and power plants, and that is the green dots you can see here on the right-hand figure. The blue ones are the wind turbines that are also spread all over the country. So we have transformed the country, the electricity system of Denmark, from a centralized to a very decentralized system, which it is today. When we do siting of wind turbines on land, there's a number of issues to consider. I have only mentioned some of the more important ones here, but the list is very long. The distance to houses and roads is very important. We have a rule in Denmark that the nearest house should be at least 4 times the total height of the wind turbine. The wind resource is also important, of course. That's the fuel of our wind farm. Environmental impact, for instance, impact on flora and fauna, and we also need to respect protected areas. The distance to the nearest grid connection is also really important. And finally, the local acceptability by the people living there is also of great importance. I have brought two illustrations of that, a distance map and a wind resource map here. The distance map is showing where we can put wind turbines depending on whether the wind turbines are 150 meters, 125 or 100 meters total height. And the taller the turbines, the smaller the area. On this side we see how the wind resource changes when we are moving away from the coastline where the wind resource is very high, and further inland where the wind resource will be less. We can see this map is overlaid with a lot of hatched areas, which is due to other considerations. So this will be repeated with a number of criteria. This is how we do siting of wind turbines on land. When we move offshore, we do a similar exercise. The issues are slightly different. The distance to land and to harbor is very important because that will determine how far do we have to transport our wind turbines when we do in the construction phase, but also in the operation phase. The water depth and seabed properties is very important when we design the foundations of our offshore wind farm. The deeper the water, the more expensive the foundations. We also try to map the navigation routes, so we will have no conflicts where the location of the wind farm is and the ship routes. The grid connection is also evaluating. We are doing that by means of a subsea cable, and we have to make sure that the sea bottom is appropriate for that and prevent any conflict with fishery, for instance. Generally, the wind resource offshore is very high and very good, but it's not constant, and we need to evaluate that before we construct our wind farm. Finally, there is a lot of environmental concerns that we need to be aware of offshore. I have only taken here one example, that is the impact on marine mammals, in this case harbor porpoises, that we need to protect them from the noise that we have during the construction of the wind farm. This is a wind resort map that we use when we find, in order to identify good locations for our wind farm. It shows the wind resource in a height of 100 meters above the sea level, and in this case for 3 years, 2007, 2008 and 2009. What you can see is that in the North Sea we have quite a high wind resource, maximum up to 10 to 11 meters per second annual average wind speed. In the Baltic Sea slightly lower, from 9 to 10 meters per second. You can also see another thing when we move closer to the shore, and we will have shorter cables, which makes the wind farm cheaper, the wind resource will be less. And if we move inside on land, the wind resource is really decreasing. Summary: in this lecture you have been introduced to the main reasons why we install wind turbines and to the key issues to consider when you are selecting a location for a wind farm either onshore or offshore.